Higgs boson,
चंद्रशेखर लिमिट,
string theory,
न्यूट्रिनोस,
quantum entanglement.
कुछ समझा क्या?
Ever felt bored and confused while reading lengthy physics textbooks or articles?
Yeah, on God, bro.
I'm Arnav,
And I'm Pratham.
and welcome to Quark Talk, where we decode all the complexities and simplify these intricate concepts in physics.
They may have seemed too complex to understand until now.
Today we're diving into one of the most iconic moments in space history, Ed White's legendary spacewalk during the Gemini IV mission.
Wait, do you mean Edward Witten?
No, he's just our favorite theoretical physicist, but he's just a theoretical physicist. We're talking about Ed White, the astronaut.
Acha, okay. So right, this was way back in like 1965.
Yeah, the good old times for you, right, Dadaji?
Shut up. So, let me get back to the point. More specifically,
Back in your childhood days.
Arnav Rai, chill. More specifically, this was on June 3rd, 1965. Okay,
Yeah.
It was the first ever American spacewalk. Ed White floated outside the spacecraft, tethered by his long gold-plated hose. And get this, he basically propelled himself around using a large pressurized oxygen gun. He turned himself into a human fire extinguisher.
That's pretty much the coolest way to float in space, right? Imagine being the first American to step out your spacecraft and just chilling in orbit looking down at Earth.
Yeah, except he liked it a bit too much.
I mean, expected, right?
Yeah,
Who wouldn't?
flight control had to literally order him to come back inside.
Ed, we are not paying you to sightsee. Get back inside.
And what did Ed White say? It's the saddest moment of my life. Now that's a man who really enjoyed his job.
But here's where things get even more interesting. After his spacewalk, they ran into a major problem. They couldn't close the hatch. Imagine being in space and your door wouldn't shut. Not exactly a situation where you can go on maintenance, right?
Exactly. For about an hour, there was radio silence from Gemini IV. They were busy trying to wrestle the hatch shut, and during that time, they actually flew out of communication range with mission control.
Can you imagine the people in Houston? Like, they'll be like, Gemini 4, are you there? What's your status? And the astronauts are like, yeah, we're a little busy right now, just like as if they're leaving them on red.
Eventually, with a lot of brute force, they managed to close the hatch. But they were so traumatized by the experience that when mission plan called for them to open it again, they flat out refused it.
I mean, fair enough, right? They barely got it closed once, and now they want you to open it again. No thanks, please.
They ended up stuffing the extra gear, basically things they were supposed to throw out, into the footwells of their cramped spacecraft. So they came back to Earth with some souvenirs.
Nice, but here's a $1 million question. Why did the hatch get stuck in the first place?
Great question. The answer lies in something called cold welding.
Cold welding, that sounds like something you'd hear in like a metal shop class.
It's actually a fascinating phenomenon that happens in space. Here on Earth, metal surfaces develop like a thin layer of oxide because of the oxygen in our atmosphere. They react. And this oxide layer, it prevents two pieces of metal from fusing together.
So basically the metal has a protective coating, right? But in space, there's no oxygen for them to form that oxide layer. And if two pieces of bare metal come into contact with each other in space and they're under some pressure or impact, they'll like fuse together, and that's called cold welding.
Wait. So basically, the atoms from one piece of metal just merge with the atoms from the other piece.
Yep, pretty much. As our another top physicist, Richard Feynman, put it, the atoms have no way of knowing that they're in different pieces.
Mind blowing. So the hatch got stuck because the metal parts literally fused together.
Yep, and remember, this isn't just a space age problem. It can also happen in vacuum chambers or even inside certain manufacturing processes here on Earth.
So what's the solution? How do engineers prevent something like this from happening in space?
So there are a couple of ways. One of them is by coating metal surfaces with non-reactive materials like gold. That's why the tether was gold-plated. Smart, right?
Yeah.
Or they use lubricants to keep surfaces from coming into direct contact.
So the next time someone says gold is just for show, tell them it's actually like high-tech space tech.
Yeah, sure. And speaking of space tech, cold welding is why astronauts need to be extra careful with tools and equipment. Imagine a wrench getting stuck to your important spacecraft bolt because of cold welding. Not ideal when you're in orbit, right?
Yeah, and that's why space engineering is so precise. It's not just about getting things up there, but it's also about making sure that they work in the most extreme conditions possible.
And that's exactly right? Because that brings us to Edward Whitten. Ed White.
Wow.
His spacewalk wasn't just a cool moment in history. It taught NASA a lot about the challenges of working in space.
Okay, but wait, hold on. Didn't NASA learn even more about cold welding during the Apollo mission?
Oh yeah, for sure. There's another famous story from Apollo 17 where the astronauts had a problem with their lunar rover. A fender broke off and they had to come up with a fix on the spot. But again, they had to be super careful because they had to avoid cold welding issues with their makeshift repairs, right?
That's classic NASA, solving problems with duct tape and ingenuity.
Absolutely. And it's a reminder that space exploration isn't just about like these high-tech solutions like gold and everything. Sometimes it's about understanding the fundamental physics and the like stuff like cold welding that can go wrong and being prepared for those things that can go wrong.
You know, cold welding in space always sounded like one of those Hollywood disaster scenarios to me. Like you'd expect the ISS to just turn into one giant welded blob of metal, right?
Right? Imagine astronauts calling out, we've accidentally welded ourselves to the station. Again.
Again, that'd be embarrassing, but apparently cold welding isn't as catastrophic as we thought.
Yeah, it's not like the biggest problem that we have because space isn't the clean freak we once thought it was. Metals up there have oxide layers, dirt, grease, and basically they're as messy as your metals at Earth, right? Because that's the same metals we're sending them up from Earth, right? So they still have those oxide layers, dirt, and grease.
So the contaminants stop bare metal from touching and fusing in space, right?
Yeah.
And the infamous Gemini IV hatch problem, well, it wasn't cold welding exactly, it was more of a sticky door.
Sticky door, you say? So space tech is basically like an old car in winter. Jiggle it, some WD-40 and hope for the best.
Sort of. Except in 1991, the Galileo's spacecraft didn't have WD-40 when its high gain antenna got stuck.
Oh, the umbrella is getting some gains. So the umbrella didn't want to open kind of situation, right?
Yeah. Cold welding pinned 3 of its ribs shut. So they had to improvise with a low gain antenna to send data from Jupiter.
Imagine the scientists like talking to each other like, John, do you have a plan B? No, Stuart, I don't. What do we do now?
But then the brightest physicist or engineer at NASA says, what about duct tape?
Funnily enough, the European Space Agency later gave actual recommendations to prevent cold welding.
Let me guess. Step 1, don't use metal in space at all.
That's close. They just suggested using plastics or ceramics where possible. And if it's unavoidable, then use like alloys or like use two different metals that might be coming in contact, because the same metal coming in contact with another counterpart would increase the risk. So if you use alloys, it reduces the risk of fusing.
So no mixing metals, like bad jewelry advice. What else?
Durable coatings to keep metals from touching bare, like basically space proofing your tech, like the gold tethered wire.
You know, cold welding, is not that bad also. Like, it's the one annoying genius kid in class. You don't like them, but they get stuff done for you.
So totally, it's a game changer for nanotechnology actually. And they've used, like scientists have been using it to perfectly weld gold nanowires without heat.
No heat? I mean, isn't that a little crazy? No risk of a microscopic meltdown then?
Yeah, exactly. That's the whole point, because the crystalline structure stays perfect. So the electrical and mechanical properties are literally the same, and it lets them create some insanely precise nanotech.
So cold welding in space is bad, but cold welding in labs, perfection.
Yeah, pretty much. Although I wouldn't mind if they figured out how to use it to fix my desk drawer. Like, the hinge is like almost like broken.
Or your desk system also. Seriously, even the ISS is less cluttered.
You know what? Maybe I'll just cold weld you to a chair next time you visit.
Shut up. Bold of you to assume I wouldn't bring WD-40.
Fair enough. So, we've talked about cold welding, but let's zoom out for a second. This isn't just about like some spacecraft or nanotech like technology, right? Cold welding touches on something even more fundamental. How materials behave in extreme environments.
You mean like how everything we take on granted for Earth, gravity, atmosphere, temperatures, all of that, goes out of the window the moment you leave the planet.
Exactly, because space forces engineers to rethink everything. Take for instance lubrication. On Earth, you slap on some grease and that famous like Fevikwik
Yeah.
or anything, and you can just fix up anything and you're good. But in space, not so much, because grease, for example, can evaporate or degrade in vacuum conditions.
Which is why they use solid lubricants like molybdenum disulfide, right?
Big words, but yeah.
Yeah, it's a compound, okay?
Yeah, it is.
It's a compound.
So that stuff is like the duct tape of space mechanics.
Totally, it's lightweight, durable, and works without needing any atmosphere. And there's the thermal expansion, or rather, the lack of it. On Earth, materials expand and contract with the temperature changes. But in space, extreme cold can make metal parts contract and seize up.
Right, like when you have train tracks, which they give space, they allocate space for train tracks, right? To expand in the summer and contract in the winter. Slack. Or when your car won't start in freezing winter, but way worse. Speaking of Mars, did you know that cold welding is also a concern for future colonization? Elon Musk is face farming right now, right? The dust on Mars isn't just annoying, it's abrasive and can strip away those coatings, those little. One of the barriers that the European Space Agency said that it's a help to reduce the risk of cold welding would be a problem by the Mars air. Like, it's literally abrasive and can strip away those and expose those bare metal. That was a nice joke. One of your first good ones.
No.
Please, okay, please, okay. Okay, so cold welding is a space problem and it's a nanotech solution. But what about the crossovers? Are there any everyday uses for this tech? Yeah, kind of like how like Formula One, like innovations trickle down to cars in our like the normal cars, right?
Yeah.
So right now, manufacturing device techniques developed for the space, they've trickled down to the medical devices, as you said, and that specifically is like, is it like the MRI machine that owes something to the space, owes something to space engineering? Aerospace. So space tech is like basically the gift that keeps on giving. All the perks, none of the flamethrowers. I'm sold. So let's talk about another cool or rather freezing application. Cryogenics. I mean, that's what I thought, right? But not quite. Because in industrial cryogenics, the equipment has to handle liquids at temperatures close to absolute zero and like liquid nitrogen, right? But the metal surfaces are under vacuum, so that means cold welding can become an issue.
Together.
Yeah, exactly. And the stakes are high in those applications like particle accelerators like CERN and all. You don't want your multi-billion-dollar circular 27-kilometer collider to get stuck because of cold welding, right?
Imagine.
Okay. So let's just bring it back to space for a moment. Let's just leave the CERN for now because it's having some issues. So we've been talking a lot about problems, but what's the big takeaway? Yep, like the Galileo antenna. Sure, it was stuck. But now we have systems in place to ensure something like that doesn't happen again, right? We're learning from our mistakes.
Exactly.
And NASA scientists and scientists around the world that send rovers to all other planets, they've done this like time and again, like for the Curiosity rover and the Spirit rover. They've done that multiple times, so it's not like a one-time thing, right? So what you're trying to say is that the next time I fix my bike with duct tape, I should tell the people at NASA that I'm using their approved methods. So before we wrap, where do you think cold welding and its challenges fit in the future of space exploration? Oh yeah, I heard that there's like 100 asteroids and like in the Kuiper belt, especially 7 of them that are worth like I think $100 trillion each, worth of some gold or some rare minerals, like worth of that. And if you just manage to get that back to Earth, you'll be literally a trillionaire, the world's first trillionaire. Like just get an asteroid back home on Earth, and that's it. Boom. Yeah, I think he's focusing on the wrong planetary exploration. He should just can Mars and just focus on the asteroid belts, right?
Yeah.
So, the like for example, you said that the vacuum and the fine metal dust in space make mining equipment vulnerable, right?
Yeah.
And on a space station or a moon base or a Mars base or a asteroid base, even minor malfunctions could be catastrophic, right? Yeah, there's another video I saw. Same thing that he built. J laser video. He built an Iron Man helmet that if you heat it up with fire and everything, even if it's crushed, it just like because it's a metal that it reforms to its original shape.
Yeah.
Because the metal remembers its original like properties and its positions. That's the point, right? And that's straight out of sci-fi, right? Yeah, and I guess that's the point right now at this point, because you need space exploration that keeps turning sci-fi into reality. Speaking of thriving, does this mean that we can look forward to a day when earthbound rules are like cold weld proof? Or rather, my duct tape.
Big.
Because I've always wanted to fix my bike while orbiting the earth.